So how do you make your own lighting rig for the Super73 Z1? That's coming right up. Hey everyone, my name is Rick Cordero. Welcome to RunPlayBack, where we help you with video and tech tips to lead a more efficient and affordable lifestyle. Let's be creative and save money at the same time. Today we're going to show you how to make your own lighting rig for the Super73 Z1. We'll talk about the parts that we used, the tools that you need, and we'll even share our wiring cheat sheet to make things easier. So let's get to it. This is the flexible LED taillight. So these turn ember on the left and right. You have a high and low beam. So we're going to try to figure out how to hook this up to the brake to engage the high beam. This is going to be our turning signal switch, as well as the high beams and the horn. A couple different wires here, a couple different colors. We're going to have to figure out what the wiring diagram looks like, but this will basically attach to all of the indicator lights and the headlight and the horn. This is the flasher relay. So this will create the flashing mode for the indicator lights. This is the motorcycle horn. So this will attach to the switch with the horn, positive and negative terminals here. There's this little bracket so you can mount it anywhere on the bike. So these are our front handlebar indicator lights. It will also function as a day running light. So this will be white to match the headlights. And then when you're turning, it'll turn ember. So these will go in the front on the handlebars. This is our rear indicator lights, and these will go somewhere on the frame towards the back of the bike. They will activate when you hit the brake. They'll turn red, and then they'll also turn ember when you signal left or right. Next is this retro moto headlight housing. You might remember this from our DIY moto headlight for the Z1. So we took it off and basically going to gut the parts out, and we're just going to use the housing. This is the Weisamike 5.75 Halo LED headlight. We actually got this for the Onyx RCR, and we really love this light, so we decided to get it again for the Z1. Super bright, it has this cool halo over here, chips on board halo. We also have this H4 harness, and this will plug in to the headlight, and then we'll run this into our power. And this is just a headlight grill that we'll put in front of the light. These are your standard plastic shims. What I'm going to do is rig this to the back of the bike, close to where the rear fender is, and this will allow me to screw in our indicator lights. And these are our indicator lights. So these will turn white when we hit the high beam lights, and then the rear should activate when we hit the brakes. Next we have these micro switches. So these micro switches, we're going to try to rig to our Shimano hydraulic brakes, and these will trigger the brake lights. So what's cool about a micro switch is that it's small, it's very sensitive, and it requires really minimal compression to activate the switch. These are common in home appliances and switch panels with small buttons, but they're really cheap and inexpensive. From what I understand, they last for a really long time, almost up to 10 million cycles. So this should be perfect for rigging to the bike. So the way you wire this is that the COM port is the negative terminal, and then you have NC for normally closed, or NO for normally open. Normally open means that the switch is open, and when you press it, that's what completes the circuit. Normally closed means that closed is off, and when it opens, that's what completes the circuit. Since we're pushing down, we want to do normally open. So we'll be using this port and this port. Negative on the COM port and positive on the normally open port. So now that we've unboxed everything, we'll show you how everything fits together. so first things first, we want to get all the tools necessary to make this lighting kit. So I'll just go over what I used. You may already have some of this stuff at home. Obviously a soldering iron. These are just some crimping connectors that I have. It's like 1,000 pieces. I ended up wasting a few just by bad crimp. So you might want to get like a large pack. A voltmeter to test the voltage in your connections. Some heat shrink to put on your wires. Some ring terminals. This is for the distro box. A crimper, and then this wire cutter, wire stripper, insulated crimper tool. Some extra wire. I have 20 gauge. This is pretty heavy duty. It can handle up to 300 volts. I used one color just to save on the budget instead of trying to get multiple colors. And then some cloth tape just to cover up some of your connections so they don't come loose. So the first thing that you want to do is measure out all of your wiring. You want to measure the distance of all of your components that are on the bike to the back. So I'm putting everything inside of the seat. So essentially anywhere that I mount like the headlight or the side lights, the indicator lights, the switch, the horn, everything I kind of like measured out so I have an idea of how much I need to cut, how much wire I need to cut. Now this is for the positive, the negative, and any other wires that need to be plugged in. I kind of like wrote down just like different measurements, like from the tail light to the seat was about 18 inches. The headlight was about 29 inches. And I gave a little bit of slack, but generally I wanted to have all the measurements done beforehand. So I'm not creating this big mess of wires that's going to take up, a ton of room in the seat. So step 2 is extending the wiring. So once you have everything measured out, you're just going to extend the wiring of all the components, okay? So we have here the H4 adapter, and we just extended the wires all the way out. Same thing with the indicator lights and the fork lights, everything. You're going to either solder or use bullet connectors. I soldered everything except for these front indicators. They already have bullet connectors on them already. Same thing with the rear. So I just made female bullet connectors on one side and then extended the wires out. So that's going to take a lot of time. It's very, there's a ton, as you can see, a ton of wires here. So take your time, make sure the connections are clean, make sure you're crimping properly and you're soldering properly and you're putting all of the heat shrink on properly, just so nothing comes loose, and you should be good. So step 3 is labeling all the wiring. So once you've soldered, heat shrank, and extended your wires to your measurements, you want to label each wire with the color that matches. But you want to make like a cheat sheet of all of your wiring, right? So I made a little cheat sheet. So green, on the tail light is the left indicator, yellow is the right indicator. So like every light is different, so I don't want to give you the colors. You want to make sure that your actual cheat sheet corresponds to what the function is, and just don't rely on red being positive or black being negative or anything like that. So do that for everything, every single wire that you've extended, and label them out. Okay, so next you want to lay everything out like in proportion to the bike. So obviously the headlight is up here, the switch is going to be close to it, the horn is going to be under the headlight, the left indicators here, front, left indicators rear, this is the tail light, this is the right indicator, rear, and this is the front, and then everything here is going to be in the seat. So just like lay everything out so you know generally where everything is going to be placed. Step 5 is you want to match everything up, all right? You want to group everything together except for the wires and the switch. So these are the switch wires. In the description, I put together just a group list of like all of the wires that you need to solder and bunch together, okay? So we wanted to avoid creating a ton of splitters for each individual wire, so we just wanted to create groups, and that's how you solder everything together. You basically twist all the wires up and then make a single wire into a male bullet connector. So I have group A, B, C, D, E, F, G, and so like for example, group A are the high beam lights, right? So this is the headlight high beam wire, and the front indicators left and right, which are the white light wires. So all of them are grouped together so that when we hit the high beam, right, all of them are going to turn on at the same time. So we have all these different groups, the indicators, right? So these are all groups. So again, in the description, I'll have all these groups so you know which wires you need to bunch up, solder together, and then create kind of like a splitter using a bullet connector. So step 6 is to create the connections, right? So to keep things small and compact, we use an Ebike junction box. This is for motor phase wires. And so you could create your own power distro box. It's pretty simple. It's just like, you know, a couple of screws. So after we attach the battery, we attach the positive and negative terminals on either end here, positive and negative. And we were using circular crimp connectors like so, and as well as like bullet connectors on each end. But this is what the splitter looked like. Pretty simple. It's just like 5 wires soldered together into one wire. This is the crimp connector. And then the ends here are all the bullet connectors. And that allows us multiple connections from this tiny junction box. And that's really all you need. You don't have to get too crazy with it. So step 7 is the horn and flasher relay. So the horn is basically this thing, and then this is the flasher relay. So these will require their own connections directly into the distro box. And you know, you use your crimp connectors, and you make some crimp connections here, right? And then you attach the horn positive wire, which is this one. So that's the horn positive wire. And this goes to the positive terminal. And then same thing with the flasher relay. You're going to have a wire coming out from the battery side where it says B, the B terminal. And this goes into the positive, into one of the splitters. So step 8 is the brake switch. We haven't quite figured out what we're going to use yet, but the brake switch can either be a reed switch or like a micro switch, or any switch that you can modify to connect when you press the brakes, right? So it connects, it makes the connection, and then the brakes turn on. Now, essentially you want to attach one side to a positive terminal on the distro box, you know, and that would go to the cutoff switch or the connection switch, and then the other side would go to the brake lights. So that's one of the groups over here. I think it was group G or something like that, to the brake lights. So step 9 is you make the connections, right? Now you want to connect everything to the distro box, and the light switch, which is this, the light switch, using crimp connectors. And so again, I'll have this in the description, but essentially it'll be like, you know, group A goes to the high beam wire of the light switch, you know, same thing with like group B would be the distro box positive. Group C is the light switch left indicator wire, which is, where is that? It's somewhere over here. Yeah, this is C. So again, you're gonna have to have like kind of like a cheat sheet. You know, this would tell you, you know, where the light switch, you know, what each color does, and you just want to match it up accordingly. But the basic idea is to take all the groups, connect it to the box, and connect it to the switch. Pretty simple. Step 10 is battery power. Now, you'll either want to draw power directly from the battery pack, or you want to use a separate 12-volt battery pack. We had this 12-volt lying around. I thought it was just, you know, easier to test with something like this. If you want to draw directly from the battery pack, you'll need to split the power from your pack to the controller, and then you do a 12-volt step-down converter. So it would look something like this. This converter is actually too small for this setup. It worked well when I had like, you know, just a few lights, but now that we have a lot of lights, we're gonna get a better converter, but essentially it would be kind of the same setup. So this is the input line from the battery. So where you split off the power from the pack, it goes into here. And then the other side goes into the controller. And then the output is 12 volts. And again, we have these wires that come out to positive and negative with these circular crimp connectors, and then they go into the distro box. The beauty of this is that, you know, you can kind of easily switch between having a independent 12-volt battery pack or like straight from the pack power. Now, step 11 is you want to test your connections. Okay, you want to make sure there's no loose wires or bad crimping areas. Actually, when I first tested it, I realized that all my crimping was not good because the thickness of the wires I was using was just too thick for the crimp connectors to penetrate through. So I actually had to strip off the end, fold it down, and just make a more solid connection. So I actually ruined a bunch of bullet connectors on my first go at it because I wasn't getting any voltage. So you just want to make sure that everything, all of your connections are like working and there's voltage going through. Use your voltmeter to test that. And you know, if everything goes well, then once you turn on the battery, you should have some good connections here, as you could see. There you go. That's the high beam switch. So it activates, you know, all these lights. Left, right? Everything's working. Right indicators. There you go. You know the relay is working because it's flashing like that. You know, you can also change the speed of the lights flashing by turning this knob over here on the flasher relay. So we know that works, and we'll test out the horn. Perfect. So I know that was a pretty quick run through. I didn't want to record every wire that I soldered or every wire that I crimped. It's just like, you know, it's really tedious stuff, but you know, there's a lot of YouTube tutorials on how to do that stuff. But I really wanted to just create the groups and give you sort of like a cheat sheet on how to group everything together if you're doing this particular lighting setup for the Z1. But yeah, if you have any questions, just, you know, hit me up in the comments and I can walk you through some of it. But it's pretty straightforward if you get any kind of basic electrical lighting like knowledge. It's not that complicated. It's just, you know, you want to have everything organized because there's so many wires. Once this is inside of the seat, I'll probably find a way to just clean this up a little bit because it is just so much. But some of this will be extended out through the frame, so it shouldn't be a big deal. So now all that we have to do is install it on the bike. So let's do it. So this is our 12-volt step-down converter. We needed something a little more heavy-duty to handle our 52-volt battery pack. To wire this up, we'll need to attach a female XT60 connector and our circular crimp connectors to attach to our distro box. You'll notice that this converter only has 3 wires, positive and negative input, and a positive output. This means we'll have to splice in the negative output wire from the battery lead. First, we solder on the XT60 positive input wire, then we solder on the XT60 negative input wire. Here you'll notice that I spliced in a negative output wire with the circular crimp connector into the same wire as our input. This negative output lead will connect to our distro box. Next, we solder on the positive output wire with the circular crimp connector to the yellow output wire on the converter. This lead will output 12 volts into our distro box. Once you're done, this is how the wiring should look. Now we need to add the heat shrink to avoid any short circuits. Take your time and make sure the heat shrink is the right size and covers everything. Now we connect the 12 volt output leads to the distro box. Remember to match your positives and negatives. Once that's done, you can attach the 12 volt converter into the Z1 seat using some Velcro and it should be good to go. So this is our micro switch, which we'll be using for both the left and right sides of the bike to activate the brake lights. We position the terminals facing down and behind the brake lever. Next, bend the metal switch lever so it creates a U shape that will activate the switch when you pull the brake lever. You can use double stick tape behind the switch to ensure proper placement and activation. When that's done, add a zip tie to secure it on the brake. Now do the same thing on the other side. Next, you want to measure 4 wires that will connect from the left and right brakes into the Z1 seat. Add crimp connectors to each wire that will connect to the micro switch terminals C and NO, or normally open. Once that's done, you'll need to find an empty positive wire on the distro box, as well as group G for the brake lights. Solder together 2 of your brake wires and add a 3rd wire with a female bullet connector. This will connect with the group G male bullet connector wire. Remember to add heat shrink to protect your connections. Next, connect the group G wires to the C terminals on both the left and right side of your micro switch. The C terminal should be the terminal that's on the side of the switch. Now you want to create a splitter for the left and right positive terminals on the micro switch. The splitter will have 2 female bullet connectors and 1 male bullet connector. Again, add heat shrink to protect your connections. Next, add male bullet connectors to the left and right positive terminal wires. The other end of these 2 wires should have the crimp connectors that attach to the micro switch. Attach this splitter to a positive output from your distro box. If you made a 5-way splitter from your distro box like we did, then you should have an available wire. Next, connect the left and right NO positive terminal wires on the micro switch to the splitter. If you connected everything properly, the micro switch should activate the brake lights. For a finishing touch, you can add some braided wire loom to clean up the wires that are coming from the left and right micro switches. So the installation is complete. Let's look inside of the seat here. All the wiring. This is the distro box that I mentioned, where the power is coming through and then split. This is the 12 volt converter, and this is actually attached to the battery, converting the voltage to 12 volts. So I had something like this previously, but it wasn't strong enough and it was getting really warm and the lights started flashing. This is what we needed, something a little bit bigger. This orange thing right here, that's the flasher relay. So this is what makes some of the lights start to blink, and you can actually change the speed of the flashing as well. Here's the light switch. We attached it to the left side. You have your high beams and your left and right blinkers and your horn. So this is the headlight. This is the Wasamic headlight that we got with the halo over here. Really bright. This is the high beam mode. Low beam, high beam. When you hit high beam, the front indicators go on, as well as these fork indicators. When you signal, they turn to amber. So signal left and signal right. So this is the tail light. This is what we used previously, the flexible LED strip, but we have everything connected now. So we have the indicator modes, as well as the brake modes and the low beam mode. But that's what that looks like, left and right. If you take a look over here, you'll notice that I have indicators on the side of the bike on the lower part of the frame. This is good for cars or vehicles that are approaching you from the side and they know that you're turning. So making a left turn is always kind of dangerous when you're on a bike. So hopefully this helps in those situations. So the Z1 doesn't really have a place to install these indicators. So I actually found these plastic shims. You could get these at Lowe's or Home Depot for like $1 for like 10 or something like that. They're really cheap. And I just zip tied them, drilled some holes, zip tied them to the frame, and then made a little hole here for the indicators. And they sit well on this side. So even when I sit, they don't get in the way of my leg. So the last thing we installed are these micro switches for the brake. So when I push this down, it activates the brake light. Same thing over here. Now I'm gonna find a way to waterproof these, but essentially they're connecting the circuit that controls the wires or group G for the brake lights. So group G, when you look at the cheat sheet that I created, is all of the brake lights on the bike. So if you take a look over here, when I hit the brakes, all these lights turn on. We also get the frame lights, the rear frame lights turn on as well when you hit the brakes. And even when you're holding the brake, when you signal, you'll still get your signals over here. So alternately, if you don't want to install the micro switches to your brakes, you can actually just connect the brake lights or group G into the positive terminal of the distro box. And that just means that your lights will basically just stay on the whole time. This is still good to be visible at night, but personally, I like to activate it with the brakes. I just think it just makes you more visible when you're stopping to the vehicles behind you. So overall, I know this was a really intense DIY project. I know there's probably gonna be a lot of questions because I did kind of skip through a few things, but you know, some of this is probably basic electrical stuff. You know, you just really have to know how to solder, heat shrink, crimp, that kind of thing, and you should have all the tools to do that. And especially some extra pieces in case you mess up, you know, zip ties, things like that. If you have any questions, comments, or suggestions to make this build even better, just leave them down below. If you want to dive into more video and tech tips, click the links on the side and remember to like and subscribe so we can help you find tech deals that fit your lifestyle. We'll see you guys in the next video.